Okay, so after how many months of not recording, I'm back and I'm recording videos on concurrency, and the content comes from The Art of Multiprocessing, that book by these people over here. And I'm going to be speaking in this video about chapter 9, and this is just going to be an introduction to the content of that chapter. In the next videos, I'll go further in depth. So, it's linked lists and the role of locking. So when working with linked lists in the context of concurrency, let's say you have a thread and you have a linked list. You may be tempted to just have the thread lock a single lock, and then that lock is for the entire linked list, and then it can perform whatever operation it needs to on the linked list, whether it be adding a new node or removing nodes, etc., etc. However, it quickly becomes apparent that this is not the best solution when you have many other threads that are trying to access this particular linked list, because now let's say this thread T0 is only actually working on like these nodes. Let's say there was another node over here. It's only actually working on these nodes, but T2 or T1 wanted to work on these nodes over here. Now they are being kept out of, and they're being prevented from doing so by the lock, even though they could have actually been doing something this one, while T0 was working. And so we see that this can lead to, I guess, the system being less efficient, because obviously this one can't work on what it wants to, because it has to wait for T0 to do everything that it's doing before it can enter before it is allowed to do anything to the linked list or attain the lock and then do what it needs to in the linked list. And this is what we call coarse grain synchronization, because it's coarse grain because it's a single lock that is for the entire linked list, as opposed to fine grained, which might be individual locks for each node. But we'll get into that later on in this video series. So let's actually have a look at, let's actually define terms and lay the background and the foundation of like this linked list example and all of these things. So firstly, the linked lists are comprised of nodes, and these nodes have three attributes. The item, this is the actual data, and you see that it's I'm not sure what it's called in Java. I can't remember, but in C++, we refer to it as template. And then we have keys. Keys are what we use to sort these nodes. These nodes are sorted by unique keys. So that means that there can be no two nodes with the same key. No two distinct nodes with the same key. And then we obviously have next. So just to draw a picture, we have this, and then the next one, it'll be pointing at the next node in the array. Sorry, not the array, in the linked list. My apologies. And then yes, and so it's going to look like this. But also we're going to have a head and a tail node, and these are going to be what we call sentinel nodes, I believe that's what they're called, and they can't be added and removed. And you may have noticed this blue writing over here saying invariant. The book mentions these things called invariants, and that just means something that should not change throughout the whole time that the system exists, basically, or that the linked list exists, from the time that it is created until, I guess, whenever, till I guess it stops being used. So it means that nodes are sorted by unique keys throughout. At no point can it not be sorted, and it should always remain sorted. Otherwise, things don't end up working as they should. And you see, here's another invariant. This invariant just says that they cannot be added or removed. That is, the sentinel nodes cannot be added or removed. They are there from the start, and nothing can be changed. And you'll notice that they don't actually hold values. These other nodes in the linked list will actually hold the values, but these two do not. And you'll see that this one is not pointing at anything, because obviously the tail node is the end of the linked list. And this video and this series of videos will actually presuppose knowledge of linked lists. So I guess maybe at some point I should come out with videos on that. But yeah, so these are the functions that we actually want to define for the linked list across different types, or I guess implementations of synchronization. So you see what I mean now. But boolean add, boolean remove, and boolean contains. So this just will return true if the thing is in fact added. So yeah, and then it will return true if it is removed. However, this one will return false if it's not added. So the case in which it wouldn't be added is if it already exists in the queue, for example. So not in the queue, in the linked list, or whatever reason it did not get added, then it will return false. Here it will return false if it already exist, if it did not exist in the linked list, and contains will obviously return true if it does contain it, and false if it does not contain it. So yeah, that's it. So these are the three things that we want to define across the different types of synchronization. The different types are coarse-grained, fine-grained. Let me actually write them out. Then I'll be okay. So we have coarse-grained, fine-grained, optimistic, lazy, and non-blocking. These are the ones we're going to be going through. I'll actually include this in the next video. We'll start off with coarse-grained, and then we'll just use that as a basis to compare to the rest of these. And